Hello, my name is Laura Modelli, and welcome to Science for Education, supporting teaching and learning in science education. Have you ever wondered why electrical wires are made from metal and why there is plastic or vinyl wrapped around them? In this episode, we are going to do some activities that perhaps will help us to answer those questions, and we will also learn how to use an ammeter. To do this activity, we are going to need batteries and their holders, a switch, a light bulb, some wires, and an ammeter. I'll be using my electricity kit from EUDUX. We will also need some other materials that I gathered from around the house, such as a coin, a piece of wood, nails, and more. Now, before we continue, let's talk a little bit about ammeters. Ammeter is an abbreviation for ampere meter. The unit measurement for current is ampere. So guess what an ammeter is for? Yep, an ammeter is a tool that we can use to measure the value of the current that flows through a circuit. Since we are using batteries for our activity, the current here is a direct current or DC. In a direct current, the electric charge only flows in one direction. The ammeter that I'm using now is an ammeter that measures direct current. The ammeter needle is on the zero line. That means it is ready to be used. If the needle is not on the zero line, that means the ammeter needs to be calibrated. There are two scales in this ammeter. We are going to use the bottom scale to measure smaller numbers with more accuracy. Here I have all the components connected in a single loop or series circuit. When I close the loop, pay attention to the ammeter. The needle moves, so that means there is current flowing in the circuit. Obviously, we will know that there is current flowing in the circuit without an ammeter, just by seeing if the light is on or not. But having an ammeter, we can know precisely the value of the current that is flowing. And for this circuit, the value of current that flows in the circuit is 0.31 amperes. Now what if I put other materials somewhere in the circuit? Let's start with an aluminum rod. The light bulb is on, and the needle in the ammeter shows 0.3 amperes. Let's try with a coin. The light bulb is on, and the needle in the ammeter shows 0.31 amperes. Now how about a nail? The light bulb is on, and the needle in the ammeter shows 0.31 amperes. Now let's continue with different materials. Let's try this rubber band. The light bulb is not on. The needle in the ammeter didn't move. Let's try with some wood. The light bulb is not on. The needle in the ammeter didn't move. Let's try with a piece of cloth. The light bulb is not on. The needle in the ammeter didn't move. From our experiment, we can see that there are materials that allow the flow of the current through them, and they are called conductors. Meanwhile, there are also materials that prevent or don't allow the current to flow through them, and they are called insulators. Before we end this lesson, let's try a couple more things, shall we? We learned from our experiment before that a metal nail conducts electricity. Now, I have a metal nail. Let's put this nail in series with the circuit. The light is not on, and the needle in the ammeter did not move. What happened here? This metal nail is coated with vinyl, which is a non-conductive material. The purpose of the vinyl on the nail is actually for lubrication. It makes it easier for the nail to go through the wood when hammered in. Now let's try some pure or distilled water. The light is not on, and the needle did not move. Now I'm going to add some table salt to the water. Don't worry, you'll understand why soon. The light is barely on, and the needle in the ammeter shows 0.02 amperes. Here, we can conclude that pure water doesn't conduct electricity, making it a good insulator, and salt water does conduct electricity. Therefore, it is a conductor. Pure water or distilled water has been through the process of distillation, where the minerals in the water that contains ions such as magnesium, sodium, calcium, etc. have been removed. Therefore, the water is left with neutral charges that don't conduct electricity. Salt is composed mainly of sodium chloride, which has ions, and therefore if you mixed it up into the pure water, it will make the solution conductive. In daily life, distilled water is not commonly used. You can buy it from the store. Meanwhile, the tap water that we use to cook and wash with, water in the swimming pool, and water in the lake or the ocean are not pure water and contain conductive minerals that make those kinds of water conductive. Alright, I guess now you all can answer our question of why electrical wires need to be made from metals like iron and copper, and why they are insulated with plastic or vinyl. Thank you for watching this video. I hope you enjoyed learning about conductors and insulators and how to use an ammeter. See you next time.